Got something a little special on the bench today. This is a Motorola Sapphire IX 1969. This went in 69 Volkswagen. This is a 12 volt 9 Sierra Mike Victor AM radio, type 1, type 2, and type 3 of that model year. It's all transistor radio. Again, does AM. 12 volts, has memory buttons on it, tone control, a little light, very basic radio. And we're going to be doing a restoration on this one. Jason does have the original knobs. We can see it does have the wires. I put temporary knobs on this at the shop. I didn't need the originals. I didn't want to lose them. So we got this going on, and things do turn. Knobs barely on there. Things do turn. That is to say, mechanically, there's nothing that seems terribly broke. I don't want to push these buttons just yet and tempt fate, but looking at it, everything's there. Everything's together, but it's seen better days. There's a lot of rust. We can only imagine what it looks like on the inside, but all of the original screws are in there. It doesn't look like it's been tampered with. We see the glass isn't cracked, but the aluminum is terribly oxidized. A lot of it's eaten away. That'll need to be restored. Top cover is just eaten away. We could probably do something with that as well. So we'll just dive into this. We'll get started. Hey, do me a favor. Hit that like and subscribe button down below. Helps me out a lot when you do. The screws for the top cover are 1/4 inch. There are 4 of them. The inner plate has a paper with all the applicable patents still there. You just pop off all the old knobs right now. Some of them just falling off like this one. You're going to use a 1/2 inch to loosen the nut on each side. Now just gently pry the face of the radio off. We can see some sort of material was on here. I don't know if this was like foam rubber or some sort of mastic or something. We'll deal with that later. Right now it's removed. Put everything off to the side. Put these 2 nuts back on loosely for now. At the time I didn't have a jar. I was too lazy to go and get one. So I'll take them off again later. But now I just put them right back on. Shaking out all the crap that's in there. Doing just a quick visual inspection inside, looking for things that are broken or detached, looking at the underside, seeing if anything leaked out, that sort of thing. And once I'm happy with that, proceed onward. You have to be very careful with these types of clips. I'm just showing how they're removed, but I'm actually pressing in these 3 teeth. I'm bending them into the middle of the circle before it's pushed forward so I don't damage that plastic grill. I have to do the same thing on the other side. I'll stress that there's a lot more preparation than you see here in the video with regard to these clips. They must all be bent to the center like you see in order to push the thing outward. There's also a bit of prying from the front with a thin piece of metal that I use to pull as I push. And now with that, I'm able to remove that front plate without any damage. That'll be put in a safe spot and cleaned later. The tuning is rolled to the higher side of the frequency band to allow for the plate to be dislodged from the hook on the right side, and then I pull the plate out from the left. A quick cleaning of the bulb shows that the filament may actually be intact on this thing. So now every mechanical, non-electrical part is going to be oiled. Everything. Even if it's something that's supposed to be greased later, the oil is going to lubricate it so it doesn't crack when I try and move it. Also flush out some of the crud as well. I have a combination of things that I'm going to use, but the first stage is oil, so it literally doesn't break when I try and turn stuff. And that means everything. I'm going to use way too much oil here, and I'm going to clean it out later, but it's more important that I don't break stuff that can't be repaired. The tuning knob uses a sort of friction plate in conjunction with the gear, and this is so that when you get to the end, instead of putting stress on the system, it causes those friction plates to spin, and those plates are just about done. They seem to be doing the job for now, and it's definitely something we're going to want to visit, but it's working for the moment. And you can see the plates are on the outer portion, like the 2 discs, and then you've got the gear on the left side. So we're seeing a combination of things here that allow the shaft to spin. And things are getting easier as the oil is applied. Things are looking good. And that gear is a bit warped over time again, but it is working. So I'm not concerning myself with things that are working fine. Pulling out the buttons as well, and the buttons do pull out. I'm not going to push them in yet until they're dealt with, but they did come out. For electromechanical things such as the potentiometers on the left side, that double stack right there, I'm going to hit that with Deoxit, get inside there. That's the combination of volume, on and off switch, and the tone knob all together on that side. So if I could just get that knob on there, we'll be able to move that back and forth, and we'll see how the Deoxit actually frees that up. Actually worked quite well. Deoxit will be used in other locations on this board, but it's not going to be used as a cleaner. I have other sprays for the purpose of cleaning the electronics in here. That's going to be used as a lubricant for the contacts. I want to show this just once. This is when you reach the end of travel and the friction plate starts slipping because the gear connected to one friction plate can't turn the other friction plate. That's just a demonstration. Now I'm going to be using regular electronics cleaner, aerosol cleaner, just to remove all the dust and grime from the circuit board and components in the back. The bulb is a TS8192, and upon better cleaning of the glass, I can see that the filament does look okay. I'm still going to put it on the meter, obviously, or put some electricity through it, see what happens. But based on the schematic, it'd be a 14.7 volt light bulb. Before I get underway with any work, and to satisfy basic curiosity, I'm cleaning up just one of the buttons, and just the top of the button, removing all the dirt and grime. I'm also oiling the plastic. I'm using some plastic treatment. And then what I'm going to do after this, I'm going to follow up with some diamond paste. I'm going to use some Moz on this, and I'm going to see if I could get a shine out of the button. And that'll pretty much tell me how the other one's going to look. So we're going to see what happens. It comes out real nice for 2 minutes of work. I think we could go with that. Let's move on back with the project. I'm going to start by measuring its factory supplied resistance values of the coils on this thing. I'm going to calibrate my meter here. And I see that through the cables, I got 0.2 on the one setting. So this is 0.2 ohms of resistance. So it's one marker. So that's what we're going to go with as an offset. I'm going to start with L5, should measure 0.9 ohms. This is showing 1.2, so there's 1 ohm with the offset. This is just about perfect. We're going to move on to the next one. I've got a small delicate coil right here coming directly off the antenna jack. It reads 0.2 ohms. We're going to measure that one now. Showing 0.4 means 0.2. This one is also good. Now we're going to measure the windings on the final transformer T3. This will be from center tap to ground. 2.2 should be the reading. Seeing 2.6, which is actually 2.4. Expecting 2.2. This is good. The other side of the tap should be 1.3. Showing 1.7 minus 0.2. That's a 1.5. So very good. We're going to be measuring the tuning coils now. L2, 3, and 4. These are tuned by the knob. This is L2, should read 2.3. We're seeing on the meter 2.8, minus 2 is 2.6, so that's good. Pins 3 and 4 will be 0.02 on the chart. And we're seeing 0.04, so that's 0.02, so right on the money. 5 and 6 should be 5.7. And we're seeing just over 6, so this is very close to, very good. Pin 7 and 8, we expect to see 1.7 ohms. And I see 2.2, so it's actually 2 ohms, so that's very good as well. Here's a 0.2 ohm resistor I want to check. I thought it was burned, but it turns out it's just rubber that was dried out. It's a wire-wrapped resistor, so I'm going to check it right quick and make sure it's good. And if it's good, I'm just going to put some liquid tape on there and call it a day. And I can see 0.4, and that means it's 0.2. This resistor is good, no problem at all. The Deoxit has had time to soak in. I'm checking the power switch now, making sure everything's working okay, and the power switch portion looks good, as we see here. And this is just a really quick check of the volume knob, not measurements, just to make sure that nothing's broken on the potentiometer, that's all. Now going to use a small inductance meter to make sure that the magnets that are moving through the coils on the tuning coils are working okay. I'll note that this third set over here, 5 and 6, has no mechanical magnet that goes through it. And they all tested good, so I'll proceed now, and I'm going to remove the bolt that holds the bracket, and that bracket holds in the circuit board in the rear. I'm going to very gently lift the circuit board up and out of the tabs and bend the wires in such a way as I have exposure to the rear of the board. We can see in the traces of this board is stamped 1968. We're going to jump right into ESR testing for the triple electrolytic capacitor. I don't expect it to work. The first 500 C21B should show 0.18 maximum. I'm showing 0.68. Not like end of the world, could probably be rebuilt, but it's way out of spec and it's garbage. I'm going to move on. The C21A, also 500 microfarad, should be 0.18 maximum. I'm seeing 0.979, so this one is out of specification as well. This is C21C. This should be 0.7, 100 microfarads. I'm looking at it now, and we're seeing 6 ohms. This is probably a dead short, cause damage if it was powered up. We're going to take a look at this when it's removed from the radio. But right now, yeah, definite garbage. This can't be rebuilt, this capacitor. Moving on. We're going to be testing the last of the coils, T1 and T2, starting with T1. This has 2 48 ohm coils within it. We'll test that now. Checking the first coil for 48, and we're seeing 52, so very close. Now we're on the other side of the coil with the other lead tied to ground. And this one's showing 50 for 48. Very good. Moving on. This other coil, T2, is more complex because we're also going to be checking through center taps as well. On this winding for 35, we're seeing 43, and that's very good, so we'll move on. This second side shows 15 for 12, also very good. On this side, in the first tap, we expect to see 49, and we see 50, so this is good. Finally, we're looking for 6 ohms with this pin connected to ground. And we're seeing about 6.5, so this one is good as well. We will now desolder the old capacitor, applying new solder as necessary onto the old solder to make it easier to desolder. I've desoldered this ground, so I'm able to lift the circuit board higher. I'm removing this clip. I can't seem to unsolder this clip, and I don't want to damage the board, so I'm going to clip it this a couple times, and eventually I'll be able to snap this off. And with that, I'm able to work the capacitor out of the board. None of the other pins are soldered in at this point. And this thing is worse for wear. There's some evidence of some electrolyte leakage. Definitely ready for replacement. I'm sure it's broken. We're going to test this thing shortly. And it looks like here, looks like last week of 1968 was the production of this capacitor. Either that or 6th week of 56, but that doesn't sound right. Some minor trace damage on the inside traces here, as we can see. That'll be repaired when the new capacitors arrive and they're installed. Just for fun, we're going to set up a quick test to see how much current these pass at the rated voltage. So the first test I did, on the left side we see the amperage. It's 50 milliamps full deflection is what I set it up for. I didn't know how bad this was going to be. And the right-hand side is the actual voltage. Get underway. Consider that I measure leakage current in microamps. We're looking at about 8 milliamps of leakage current on initial turn-up. I should see about, an old capacitor like this, maybe 500 microamps, 0.5 milliamps. So I'm not even at 5 volts yet. It's supposed to be rated at 16 volts. And as I turn up the voltage, we can see the current is going up with it significantly. Almost at 20 milliamps. Drops down as it takes a charge. But as I turn, the voltage goes back up. This might in fact be due to a degree of reformation within the capacitor, but by no means does this make the capacitor any good. I ran the cycle slowly, sped up about 1,000 times, but even so, just at about 14.5 volts, I was able to get this as high as 50 milliamps going through here, so this is pretty bad. I'd like to do one more quick test with this capacitor on the other lead. Now I've hooked it up to the other lead, and I'm setting the current range from 50 milliamps to 500 milliamps, so half an amp. And the voltage is set for just under 15 volts, just like last test. And what happens is, as I turn on the device, I only see a bump with a couple volts. And I'm trying to figure out what's going on. And it's not until I turn it off that I hear the safety relay click that I realize that the overcurrent relay has shut off the power supply. So I can reconfigure it for 10 volts, 500 milliamps. So when I turn it on, it pegs the meter. So I immediately flip it over to 1.5 amps. And when I do, we could see that it was almost full tilt at 1.5 amps at 10 volts. So that is packing a punch. This thing's almost a dead short. We can imagine that if this were plugged into a car and there were no fuse, the current going through here would be like a dead short, whatever circuit it was connected to. This capacitor would either fry whatever circuit it was in, bust a fuse, or destroy the radio. We'll repeat with a modern capacitor. It's a 25 volt, 10 microfarad capacitor. I've got the range here set for 50 volts. There's some residual voltage on here right now. And this is set up for 50 milliamps on the scale on the left-hand side. To click it on, we could see that as the voltage climbs, the other needle just bumps just for a second as it charges. There's current when the capacitor charges, but that's it. And then it goes right back down. So see as I turn it up, charges, drops. Charges, drops. That's what it's supposed to do. It's immeasurable on this device, as it should be. Okay, enough testing the capacitors, moving on. While I'm waiting for the capacitors to arrive, I'm going to start cleaning up this device. I'm not going to use compressed air. I don't want to risk damaging any components if I don't have to. We could use a brush. The outside was more about looking at the overall condition, seeing if there's any rust or wear. And put the light bulb back in now as this area is clean. Outside looks fine. Inside is now clean. And top looks good. I'm going to apply lubrication to the areas that require lube now. Go through a process. Gears, surfaces that have friction points and what have you. Do it in different intervals so it collects evenly around the gears, mating surfaces. Now I'm going to do the rest of the buttons, get them all to a nice shine so I could end this button project. I'll probably come back again with a Dremel with a buffing wheel to get a final shine on the end of the buttons, but right now I just want to get the nastiness off of them, so this is done. Now I can do the cover. I'm going to hit it with some Windex. This is not the side of the cover that has the numbers on it, so this is the external side. There's the other side. So I'm going to spray it and get this crap off of there. And the other side, it's recessed where the lettering is, where the white paint is, so you don't really have to worry about taking the paint off. Or you could easily reapply the paint if you did remove some of the paint. But there's some of that mastic or rotten foam rubber that I got to remove. But it came off and it did come out rather nice. Try to work those last remaining pieces off. A couple of scratches, but I put my hand behind for perspective. Looks real nice. This will be a good fit. New capacitors have arrived. We got the 100 and the two 500s, all at 16 volt rating. We're going to drop them into this board that I have to repair the traces as well as we do this. Pre-applying solder paste to the damaged traces on the top side of the board, and then the bottom side of the board. Mixing a small amount of new solder with any residual old oxidized solder in all of these affected traces. Not a lot of solder, just a very little bit. Start with the 100 microfarad first. It's the smallest. We'll get that out of the way. I've chose axial to make it easier to install these, and the ground will always be overhead and wrap around, because I didn't know if a bad trace was going to cause me to have to move the ground to another location. This is then followed by the first 500. I have to leave a little bit of space to work on the top side of the circuit board. The goal is not just to get a good solder connection here, but also to wick some of the solder through to the other side of the circuit board. Now making sure that there's good solder connectivity on that side, as well as repairing those traces as I see that there's an issue, using flux as well as solder, getting in there one last time before the third capacitor goes in. And with that, I drop the third capacitor in now. And then I repeat the same procedure for the third capacitor as I did for the first two. I've clipped the leads shorter but not off. I haven't yet committed to this installation. Obviously, I want to test first before I clip them all the way to the circuit board. And there it is. That's capacitor job completed. And with that, we're going to call video 1 of the series done. When the next video comes out, I'll put a link up in the top right corner. I hope you enjoyed this video. Hit the like button down below. Helps me out a lot when you do. Thanks for watching.
Thanks for watching. Would you like to reply?